Okay, hello. This is a presentation that I wanted to do for a long time. In this talk, I'm going to present a library called Helenus. This is probably going to be structured in 2 or 3 sessions, and in this session we are going to mainly take a look at the synchronous API. I know that that's not the most common way to approach the library. Usually we work with either streams or a synchronous API, but I think this is a good introduction to the library. So let's get to it. So this is Helenus. So Helenus is library that lets you communicate with Apache Cassandra. It's a Scala library that tries to make your life easier in a type-safe manner, although there are some caveats there. And its main purpose as well is to avoid introducing a complex API. So that's what Helenus is. Now, a lot of you may be thinking, why should I consider this as a library to communicate with Cassandra? Why not use something like Phantom or Quill, which are well-established libraries? Well, to be honest, currently we are using Helenus on the project that I'm working on, and we tried in the past to use libraries such as Phantom or Quill, but they didn't match or entirely match the way that we approach communicating or working with the database. In a sense, a Phantom and Quill works a bit like an ORM, so hiding a bit the complexity of the database and letting you work with Scala types directly. So obviously there are some advantages and disadvantages of doing that. Even Helenus suffer from some of those disadvantages, or has disadvantages of its own that Phantom and Quill doesn't have. But I think that some of the upsides of using this library outweighs the downsides. So one of the things that we believe is that we should put our queries, put them in center place. We believe that those are the most important things, like letting you control what queries are going to be executed, and not those being hidden behind some abstraction. And also considering that, or we consider that the source of truth regarding the schema or the queries or the execution lies on the database, not on the code base. So if anything changes, type safety on your Scala project is not going to save you from well, some exception or some query misbehaving. So yeah, we believe in those two things. So in a sense, Helenus takes inspiration a bit from Phantom, a bit from Quill, and a bit from ANORM. So ANORM lets you define queries and then provides you with some tools to do some mapping from SQL to Scala types. Helenus follows a similar approach. So you can find the project in this URL, and from here we can access a simple README of how would it work. But in this talk, I'll give you an overall idea of how we would use the library. We also have a wiki page which defines roughly the same motivation as the README, and also introduces or mentions some concepts. So Helenus builds on top of the concepts defined by the Cassandra Java library. So meaning that, or at least we have 3 concepts to keep in mind. So prepared statements, bound statements, and type codecs. So prepared statements are a way to define DML operations such as select or insert. We usually define a string literal as being the query, and we give that string literal to the session so it can parse it and validate the query. There is another way to do it on the Java driver, and that's by the query builder or the statement builder. But Helenus tries to just let you define it in the same vein, let you define queries as string literal instead of introducing some way of composing strings or composing some builder pattern to build strings. Then we have the bound statement. So a bound statement is or an instance of that we obtain from a prepared statement whenever we want to run the statement against the database, and we have defined some query parameters. What we do is we bind those query parameters, we instantiate a statement, and then we execute it. And then we have type codecs. So type codecs tells the driver how to encode or decode a particular JVM type, whether that be a simple type like a string or an int or a boolean, or even a more complex type such as a collection or a user-defined type or UDT. So in this, from these concepts coming from the driver, Helenus introduced some concepts of its own that kind of like relate to the ones introduced by the driver. So on the one hand, we have Scala prepared statements. So these are extensions on the previous prepared statements. Actually, Scala prepared statements are prepared statements, and they introduce some helper functions or some utilities, such as that we can treat Scala prepared statements as functions, as we'll see in a moment. Once we have a Scala prepared statement, we can also construct or create Scala bound statements. So this is when we bind parameters to a prepared statement. Then we have a RowMapper. So a RowMapper is an abstraction that tells Helenus how to map a row coming from a result set into a case class. So depending, there are different use cases for RowMappers or different ways to define them. In some cases, RowMappers have to be defined explicitly for some types, whereas for some other types they don't. They are derived implicitly, as we'll see in a moment. We also have adapters. So adapters, and I'll explain during the I'll explain how these work in a moment. But basically, they let you adapt a Scala type, such as usually a case class, into something that a prepared statement can use. Then we have a mapping. So a mapping, if we have time, it's a concept that was added recently and brings these two previous concepts together. So an adapter and a RowMapper. The original goal of a mapping was to be able to define queries that would have more than 22 bind parameters. We'll see why is that, but originally was introduced like that. But then we thought that it could be a nice idea to introduce a kind of like an ORM feature into the case classes, so combining these two concepts. Then we have a column mapper. So a column mapper tells Helenus how to map a case class field or a field that we are querying into different columns. So usually by default, one column means it's mapped directly to one field, so there is a one-to-one relationship. But we know that schemas can be different, and maybe instead of using a UDT, we define 3 columns to create a case class. So in this way, a column mapper lets you bundle those that behavior of grouping those 3 columns into a single case class. Then we have column naming scheme. So this is how fields are translated into case class fields. In this case, are translated into columns. Sometimes the preferred way on Scala is that we use a camel case to define fields, field names, whereas in Cassandra or usually in databases, the naming scheme is with underscore, so it's a snake case. And finally, I'm not sure if you are going to cover this, a pager. So pager lets you iterate through results in Apache native fashion. Its purpose is a take on the pagination algorithm, trying to bring the different paginations that we have either when we are doing a reactive execution or a synchronous execution, trying to bring everything under the same abstraction, whereas all those cases, they work slightly different on the Java driver. So we'll see that with Helenus we can do 2 things. So we can, whenever we are defining statements, ScalaPreparedStatements, we can treat those statements either as functions, or we can define them as functions, or we can define them as interpolated statements. So kind of like we'll see how we can define, just like anorm or Scala, we use a string interpolation to define queries. So the wiki goes in great detail of how the library works and the different features. So let's jump onto the code and let's see how that works, or how we would approach a migration to Helenus. So again, this is going to tackle the synchronous API. I know that's not the most preferred way to work with Cassandra or with any database whatsoever, but it's a way, a nice way to introduce or to approach the API. One thing to say is that whatever the synchronous API handles, also the asynchronous API handles in the same way. So we're not missing anything. We just have to change the name of the functions. So this presentation is it's based on definitive hotels. So there's a book by O'Reilly called Definitive Cassandra, and that goes and defines a schema or a domain based on hotels and reservations. So in this case, we're going to tackle only hotels and how to work with that, instead of like running and making the presentation longer by introducing the same thing over and over again. So here, in a sense, what we have is we have a schema that is composed by 5 tables meant to be run or to answer 5 queries. So in this case, we have find hotels by point of interest, find information about a hotel, find points of interest near an hotel, then find available rooms by hotel and date, so if there is a reservation, and then find the amenities of a room for a given hotel. One thing to notice is that we also have a UDT, so the address is expressed as a UDT with 5 fields. So okay, let's start with this. So the first thing that we can do, and this project has tests running against a database. So actually, let me jump into shell mode. Yeah, so all the tests run successfully, but just so we can have it there and don't have to recompile everything again. We'll do it from there. Okay, so usually the way that we would approach working with Cassandra in our project would be something like this. So we would have a repository, we would have an object defining the queries, although it could be, let's say, on the companion object of hotel repositories, but yeah, in this case I decided to make it simple. We would also have access to a SQL session. I marked this session implicitly out of convenience. I'll show why when we include Helenus into the project. But once we have done that, we have one query for each method. So let's say that what we do is we execute a query by binding the point of interest name. Then we get all the values for that query. Then we have some conversion methods here, so because usually this returns a Java list, so we have to go into a conversion to go to Scala, to a Scala collection, and then from that we want to map the values from the result set to some object, some domain class. So in this case, we are, let's say, grabbing a row, and we're going to get grabbing each one of the columns that we see on the field, on the road, such as the hotel ID, the name, the phone, and also we have to do some translation for the address. Then the same thing will happen again. We would do and find the hotel by an ID, and do the same mapping again. Although here in this case we will have to also we can also have the point of interest. That's a column that is a set of strings. But again, like this, the Java driver gives us Java collection, so we will have to do a Scala to do another conversion. So here there will be another conversion, and here of course we also have to produce a conversion from the UDT value to an address instance. And the same thing will go on and on, right? Like we would have to have our converters, we would have to convert from Scala, from Java, and we would have to go back and forth. So this was one of the things that we wanted to ease or to simplify by introducing Helenus, avoiding all these Scala to Java or Java to Scala conversions. One thing that I would like to know is that another thing that we wanted to do, although this is, I think this has been alleviated by Scala 2.13. Usually, whenever we want to bind values to a prepared statement, we use the bind operator coming from the prepared statement, so from the Java driver, and this would take objects. So if we had, so as we know, object in Scala is any ref, and whenever we wanted to use, let's say, a primitive, then we would have to do some casting. Otherwise, the compiler would complain that, yeah, I wouldn't know where to find this overloaded method, because on the one hand we were providing only objects or any refs, and here we are introducing an any val, and yeah, the compiler will know where to find a method that will be var args of any. So another thing that we want to simplify with by introducing Helenus, like first class support for any vals. Then let's take a look at the queries that we define at the top, right? So we, as I mentioned, we have all our queries defined in an object, and then we can access those prepared statements like this and execute them. So let's go and take a look at that. So first of all, what we do is we have to register a codec, right? Because even if we have a case class and we can convert from UDT value to case class back and forth, we still need to register a specific codec for that user-defined type that we can also see here, right? So the UDT is we have to specify what's the key space, what's the name of the SQL type, what are the fields, and what are the types of those fields. And you can see here that like there is some mapping and some conversion, and yeah, like there are some pain points here, or this is either cumbersome or error prone, because the moment that we make a mistake, either on the type definition or the names, or even when we pull the values from the UDT value into the case class. So yeah, let's continue. So once we have that, what we do is we also have the different statements or these different queries, and what we do is with the session we prepare those queries, and once they are prepared, well, they are ready to they're ready to be executed. So one thing that could happen, right, like one thing that the driver doesn't tell us, is that we can simply say we know that by point or by point of interest is a query that takes only one parameter. Nothing would prevent us from introducing another parameter, like the compiler wouldn't complain. Actually, so if I run the test again, the test will run, so the compiler won't complain that I'm introducing an extra parameter, and yeah, I will just have an exception at runtime saying, hey, you defined too many variables, or you provided too many variables. So that's also one of the things that we wanted to avoid with Helenus. So let's go ahead and let's refactor this application to use Helenus. So as the README instructs, so the installation is pretty simple. The only thing that we need to do is we need to add this to our dependencies. So let's go ahead and do that. Yeah, so let's see. Wait until that's done. Yeah, great. So the first thing that we need to do is we need to import Helenus into the code base. The second thing that we had to do is we would have to mark the session as implicit. So we already done that, so there's no need to no need to do that here. Well, although if you are going to introduce Helenus, this is something that you need to do. So once we have that, so the next thing to do is we need to translate these queries into ScalaPreparedStatements. So here we can see that we have a prepared statement. Let's translate that into ScalaPreparedStatements. So the first thing to do is that we can remove the prepare part, and we can just translate this to SQL. Now, once we have that, what we have done is we have wrapped the string into a context, and we can prepare one of these queries with a prepare method. So there are different prepare methods depending on the amount of query parameters that you want to that this query defines. So in this case, this query prepare defines only one query parameter. So let's go ahead and prepare. So we know that by knowing the schema, we know that point name is of type string. So let's go ahead and do that. So once we have done that, we see that the type of this is a ScalaPreparedStatement 1, so means that it takes one parameter of type string, and then the output of that prepare statement is a row. So what we can do is, so we have done the mapping, we have translated, or we have defined the previous prepare statement as a ScalaPreparedStatement. So let's go ahead and let's run the tests. SQL is a member of string. Okay, what's going on? Oh, right. Yeah. Sorry. Yeah, I had to reload the project. of course. Yeah, okay, so let's run the test. So, yeah, so have you seen I modify the query and the type, but this still works. So the tests don't break. As I mentioned, a Scala prepare statement is also a prepare statement, so the same code executes. One of another thing that we want to provide with Helenus was try to ease on the migration and also simplify or provide some integration points. So there are some the code that works should still work, and we could even in some cases use Helenus from Java. So okay, so we have a Scala prepare statement. Let's see if we can actually simplify this and make it more Scala-like, so to speak. So what we have is we have some queries, right? So and in this case we're using by POI. So let's see what we can do. So once we have this, one thing that we can do, as I mentioned, is that we can treat Scala prepare statement as functions. So I can see that I have an apply method that takes a string. So the string is the input parameter that or the bind parameter that we define in the query. So let's take a look and let's execute that. Or let's create a bound statement from that. So let's define the POI name. So that's what we want. And here we see that we have a Scala bound statement. Now the compiler is complaining, and it's complaining because I also need to introduce Helenus in this context. So once I have done that, then the compiler doesn't complain anymore. And here, notice I have a Scala bound statement of row. So the output type of this execution. So let's go ahead and let's see if we can do this. And then what we can do is so once we have this, the next thing that we need to do is we obviously need to execute, right? So we already have the bound statement, but the bound statement on its own doesn't do anything. We need to execute that. So let's go ahead and let's replace it here. So notice again, so I only had to remove the part where the execution came, and now if I run the test, then yeah, this should work. Yeah, so far so good. So now, yeah, we are introducing that, and one thing that I could do is if I try to do this, if I try to, let's say, this is something that the Java driver won't let me know, is that obviously I have defined the query as its input parameter or its bind parameter as being of type int. Here in this case, I'm having it with if I misplace this, I can just, yeah, I get a compiler error. So yeah, we can treat queries, Scala prepared statements as functions. There is also a shorthand syntax. So whenever we don't want to create a bound statement, we just want to get the results, what you can do is we can just say, okay, so there's also an execute method on the prepare statement that lets you execute in one go. So we are skipping creating a bound statement. So once we have done that, we can just run the test again, and then this would work without a problem. Now we're still doing a lot of conversion, right? Because we're still like mapping it to Scala and to a Scala collection, and then we're like going through that. So let's see if we can change that, right? So the thing that we can do here is we can do once we have a paging iterable, what we can do is we can actually convert it just like we would do with a collection. So we could say do list. So that would give us a list of rows. And once we have done that, then we can simply do this. So if you notice, I'll check the def. So one of the things that we were able to do was to get rid of the collections converter going from Java to Scala. We could also simplify how we executed the statement, and now we also can convert it in one go. Yeah, so that works. So one thing one thing that we would want to maybe simplify as well is how we can convert this, right? So let's say that here we can see that whenever we have a UDT, we have to specify the types, the names, the schema, and whatnot. So Helenus allows us to do something way simpler for this. So let's put Helenus into the into context, and whenever we, as I mentioned, whenever we want to map a column to a type, whatever that type is, we usually have to introduce these type codecs. So let's introduce a type codec for address. That would be the UDT codec for this. So what we can do is we have to define this as an implicit value. So type codecs are carried along implicitly in Helenus. So let's do codec, and then we want to introduce a type codec. So this is not the only place that we could do it. Instead of polluting the domain models, we could introduce this codec in a package object and define all the codecs there. But yeah, due to implicit resolution, let's do it here. So once we have this, we have marked a type codec, and we want to construct one. So that's pretty simple. We can just say UDT off, and then we specify what's the type that we expect. So this would be of type address, and now let's get rid of all this because we don't need it anymore. So once we have that, we have a type codec. Let's get rid of this. We don't need to translate an address to a UDT value, so we simplify that. And finally, what we do is we have to, well, get rid of that, but we also have to, so we don't need to register the codec anymore. That will be done implicitly. And then what we want is we want to, let's do this, but we are going to ignore those tests. We don't need to have them anymore. So what we can do is we can avoid doing all these conversions. So let's oh, sorry, wrong method. So let's do it here. Let's do something different. So here what we can do is we can say, okay, so we have a method that we are going to use. So something simple that we can do is we can remove this, and then we have some extension methods on rows, so we can actually do get call, and we know that this is of type string, so that should be it. And finally, what we want is we want to have a row, we want to get a column of type address, and the column name is address. So let's go ahead and let's introduce the same thing here. So let's copy paste, why not? Let's do that here, and we get rid of that, but we also need to get rid of, or we can also get rid of the conversion here. So Helenus provides by default out of the box type codecs for collections. So we could do a set of string, and this would be boy, and we simplify that. So let's go ahead and let's run the test, although I think that the insertion will fail. Let's see. hotel ID is not a column in row. Oh yeah, of course. This is like this. Yeah, copy pasted the wrong thing. Okay, so the insertion fails as I expected. We'll see that in a moment because it's expecting a UDT. We'll see how we can simplify that. So in a way, what we can do is we can just get rid of this. We don't have to translate from a Java set to a Scala set. So let's see if we can also do something with this query. So this query has an optional hotel. So one thing that I mentioned in the beginning was this idea of RowMapper. So a RowMapper lets you map a row into a case class. So let's take a look if we can introduce that abstraction to get a hotel. So a hotel, if we can see, it has an ID, a name, a phone, an address, and some points of interest. Now, if we go back to the schema, we see that these are exactly the same values that we had in in hotels. It's not necessarily the same that we have from Boy and all the others, but it's the same thing that we have here. So that tells us that we can probably introduce a RowMapper because we have access to each one of the fields. So let's go ahead and let's do that first of all. So let's introduce a RowMapper because we want to map from rows to hotels. Again, we have to do this, define this as implicit RowMapper. So mapper, RowMapper, no. No, hotel. And then we can simply do RowMapper of hotel. So what this will do is this will find in a row the columns with the same names as the fields that we have defined. There is also a way to do as I mentioned, the column naming scheme. So we could have an implicit val, and this would be a snake case. If we want to, in this case, it won't matter because we don't have fields with 2 or more words, so it won't make any difference. And as I mentioned, yeah, this could be all the naming scheme and all the mappers and all the codecs could be defined in the package object for the repositories, and then we would have everything in a single place being consistent and not in one place being snake case and in another naming scheme. Although that's also entirely possible. So once we have the RowMapper, what we want to simplify this. We don't want to map each one of these rows manually. We want to make use of this RowMapper. So let's take a look, right? So we have this by ID. So let's do that. So one more time, let's compare this. So this is a prepare statement. So let's remove that. Let's convert it to SQL. We can prepare. Notice that just like we have in the Java driver, we can also do prepare async to prepare the statement asynchronously. But yeah, as I mentioned, we are not going to cover that here. So what we want is we want to prepare a statement that takes only one query parameter. That's of type string. That's the ID. And so far, what we have is we have just like we had in the previous case, we have a ScalaPreparedStatement 1 that takes a row, that takes a string and produces a row. What we can do is we can use the as method that takes an implicit RowMapper, and in this case we want to get hotels out of the query. Now let me put this here, and if you notice, the compiler doesn't complain. Like, this is still possible. It's still possible to bind and get one value. So actually, let's go ahead and run the test, and you'll see that find information about an hotel, it's still green. So we can, the way that we can simplify this is that we can treat this and pick up from, notice that whenever I execute, I get a paging iterable of hotel. So let's execute that with the ID. So the same ID that is being currently used here. And once we have that, I have a paging iterable no longer of rows, I have a paging iterable of hotels. And what I can do is I can use 1 to get the first result, although this could also be out of this method. This method comes from the driver. If there are no results, it will return null. So usually what we do is, like we do here, we wrap this into an option. So let's go ahead and let's remove this, remove that. So as you notice, we have simplified all this code into a single line that produces the value. So let's run the test. Let's see if it works. So yeah, that works. Still green. Now, one thing to note is that 1 lets you iterate results 1 at a time. So once you can call 1 and you will get the first result of the result set. You call 1 again, it will give you the next result. So usually this is meant to execute to provide 1 value. So the thing that we can do is we can actually call next option, and that would wrap the value on an option, so we don't have to wrap it ourselves. Kind of like it would be the same as we would have a Scala iterator where we have next options and whatnot. So okay, let's run the test, and this should go and look the same. Okay, cool. So that's roughly it. We have talked about Scala prepared statements, Scala bound statements, RowMappers. So let's see if we can also get away from introducing prepared statements like this. Let's see if we can use interpolated queries. So one thing that we could do is we could do something instead of preparing. We can also, let's do this and simplify it like this. Unfortunately, we don't have straight margins, but one thing that we can do is we can, just like anorm, we could say that this is the hotel ID type string, and we can use a string interpolation to inject the value there. So let's go ahead and we can just define it like this. So with the SQL prefix, we define that this is an interpolated statement, and we use hotels ID to execute this. Sorry, to bind this. Now notice that this is a bound statement, so we no longer have we no longer have prepared statements, because yeah, like we are preparing and binding at the same time. And let's say that this is going to be yeah, let's say that this is going to be a we say a point of interest. So now if I do this, then I should be able to go back, and now this is obviously complaining because yeah, it's no longer a prepared statement. We can actually execute it. So execute this. Yeah, we should be able to execute this. Anyway, so let's change that and let's execute. So once we have a Scala bound statement, we can execute that, and this will give us a paging iterable of points of interest. Now again, we can also convert this to a list, because that's what we want, and let's remove this. Now notice that all the code is gone and we only have one single line. Now let's run the tests. Now what it says obviously is that it cannot find an implicit value for RowMapper for point of interest. So that's what we that's what we have to produce. So let's go ahead and let's go to point of interest. Let's define a companion object. Yeah, so now that I have provided that, I should be able to run the tests. And yes, it should work. So find points or points of interest near an hotel. So one thing that I did, and this is kind of like leading to that, is that I cheated a bit. So if you see the statement, it says that I'm selecting points by hotel, and I'm mapping the point name to name, and description I'm just leaving it like that. And the reason why I'm doing that is because actually the name in the case class is name, it's not point name. So if we go back, we can see that hotel by point is point name, and then point name is duplicated, or let's say used in other tables. So let's see if we can get rid of that. So actually, and this is a part that we can't do anything at compile time, right? Because even if we define something like tables, like Phantom or Slick would do, the source of truth, or where these names are defined, is the database. It's not being tracked by the code base. So here, yeah, we can see that this is name. It's not a column on this row. So let's see if we can rename that. So the thing that I want to do is I want to be able to rename this into from name to point name. So let's do that. Let's call renamed. So rename takes a type and takes different arguments. That in this case I want to select name, and I want to have point name. So this works a bit similar to how it would be done in Quill. So now if I do that, I run the tests, then now the execution works, or the test works okay. Okay, cool. So now we know how to rename fields, or redefine the field, the mapping between case class field into columns. So let's see if we can fix it. Let's see if we can fix the insertion, right? Like it's failing right now. Same thing, same all. Let's convert this to SQL. Let's prepare. And here in this case we have a string, that's the ID, a string, that's the name, a string, that's the phone, and then an address, that's the address, and then a set of strings, that's the name of the point. So once we do that, then we have a ScalaPreparedStatement of that takes 5 parameters and returns row. Unfortunately, this is, well, how the Java driver behaves. Even if we are doing an operation that doesn't return rows, we still get row out of that. So let's see if we can fix that. So here we have the hotel. We have to convert. We had to do a conversion, like you can see here on the div. We have to convert this to UDT, and we also have to do a conversion for the set. So now what we can do is we can actually introduce this, and we can execute. Let's copy this and let's put it here. Now let's delete this and let's delete that. So that's it. Let's get rid of the conversion. We don't have the conversion anymore, and that's it. Actually, this is just, again, this is also cheating because I should be able to do it like this, and it should work. So again, everything simplified to a simple line. Now, if I run the tests, this works fine. This works great. Now, why am I fixing this? Why am I showing you this? Because I want to tackle the next abstraction that Helenus provides. So if you notice here, what we have is, if we add a type annotation, what we see is that we have a Scala prepared statement of hotel ID, string, and string, and string. Yeah, I can't remember if I had types for this, but yeah, let's say it's this, right? This in a way is the way that is defined is that we have these type parameters, but probably what we would want to do is we know that we are going to give a hotel this here, because this is coming from hotels. Like whenever we are querying this table, we are getting hotels back. So we should be able to put hotels in, right? So let's see if we can do just that. So we go in and we prepare the statement just like we do here, but what we do is we also say that we want to prepare it from an hotel. So now the compiler is complaining because it cannot find an adapter of these types, and the way that it works is that it treats this as a tuple and expects an adapter, an implicit adapter that can know how to map from an hotel to this tuple. So let's go ahead and let's introduce that. Let's see if we can introduce an adapter. So let's do implicit adapter. And this is going to go from hotel. That's what we want to put in. And we are going to get a type. Now, from this, yeah, we could introduce a new adapter and do the mapping ourselves, right? Like we are doing now, like we are doing on the actual execution, because we are telling on which field it goes, what's the order and whatnot. But we don't have to do that. So we don't have to duplicate this code. What we can do is we can just say build. We can have an adapter, and that's it. So long as the fields are defined in the same order and have the same types, then it should be okay. We don't have to do anything special. This is just like RowMapper and so many other things. It's relying on shapeless to come up with an implementation for these instances. So now that I have that, this is complaining, and we can see why. So if I inspect this type again, we can see that I have an adapter Scala prepared statement that takes an hotel and has some adaptation there. So here now we no longer have to specify all this mapping. We can just specify a hotel. Once I do that, then I should be able to run the test and that will pass. Yeah, so in this case, an adapter, what it's doing is trying to adapt how we prepare a statement into a more complex type. We could also provide this explicitly instead of relying implicitly in case we want to do a mapping in a more complex way, or like we were doing the mapping here. In this case, it's no longer required. So let's remove this. So far we have checked all the all the abstractions that I wanted to show. There is only one left, and to be honest, I didn't try this, so let's see if it works. So I mentioned that we have this abstraction called mapping, and that brings these two concepts together. So let's see if this works. So what we want is we want to introduce mapping for a hotel, and we can do that. Let me check. Yeah, that should be it. And this mapping also allows you to rename how fields are mapped. So let's delete that. So once we have that, a mapping is also a RowMapper. So we don't have to do that. And the way that we would do this is we would combine these two things, because we no longer are defining the query in terms of the fields that we put in. We can simply say from here, we can say prepare from, and we provide what's the type that we want to prepare it from. So let's see, I didn't try this. Let's see if this works. So in this case, the execution works okay, because this is a Scala prepared statement mapped that goes from hotel to row. So let's go ahead and let's try to do that. And yeah, it worked. So here we can insert hotel properly. Now, one thing that we could do is we could also rewrite the previous query, where we are getting the query from here. So notice that here we are specifying the type. So in this case, we could simplify this with prepare from hotel and returning a hotel. So it's not this is not the intended way to use it, but we could think that we could provide a hotel and with some values, and then yeah, the execution could go either way. Although, yeah, this is not its intended use. It's just a way of simplifying, as I mentioned, this ORM feature to go back and forth. So yeah, that's basically it. If you want to check this out, the library is available on GitHub, and is also available on Maven. So if you look for Helenus, you will find that that we have all these different versions. So yeah, I hope that you give it a try, and come back to me and tell me what you like, what you didn't like, if you find it helpful or not. So thank you.